so that the slope of an adiabatic curve at any point is gamma times the slope of an isothermal curve at that point. So we have to show this, okay? To show slope of adiabatic curve equals gamma times the slope of isothermal curve. So we have to show this. And in order to show this, we are going to use ideal gas equation, okay? PV equals nRT, and in this equation R is constant, okay? And let us consider n equals 1. Therefore we can write PV equals, okay, RT. Clear? So this is equation 1. So we have this. Now let us first discuss, okay, isothermal change, okay? So we are going to find first the slope of isothermal curve, and we know for isothermal process, okay, temperature is constant. So therefore from equation 1, okay, for isothermal change we write PV equals R, and R is constant, and for isothermal change or process temperature is constant. So equation 1 can be written in this way, okay, PV equals constant. So we are writing equation 1 in term of isothermal process or change. So let's call it equation 2. Now we need to differentiate, okay? Let us differentiate, okay? Differentiate equation 2. So we have two variable, pressure and volume. So let us differentiate with respect to volume, okay, both side. So what we get? P dV by dV plus V dP by dV equals 0, okay? Derivative of constant is 0. So this gives me 1, okay? So we can write P plus V dP by dV equals 0. So we can write, okay, after simplification, P dV plus V dP equals 0. Now from this equation, okay, we can write P dV equals minus V dP. So let us find this, okay, dP by dV. So this equals minus P by V. So we have this, clear? And this ratio, okay, on the left hand side gives the slope of isothermal curve. So we need to understand this. So I'm writing in this way, okay? dP by dV, and this is for the isothermal curve. So this is the slope of isothermal curve. This equals minus P by V. Let us call it equation 3. So we have this. Now for adiabatic, okay, adiabatic change, that is we are going to find the slope of adiabatic curve. And for adiabatic process, okay, we write this equation PV gamma, okay, equals constant. So we have this, and let's call it equation 4. Now we differentiate, okay, and we need to understand pressure and volume, okay, are variable, okay. So let us differentiate equation 4 with respect to volume, okay. I can also differentiate with respect to pressure. So P dV power gamma by dV plus V gamma dP by dV, this equals 0. So we can simply write P gamma V power gamma minus 1, okay. So we have this plus V gamma dP by dV equals 0, and after simplification, okay, we can write P gamma V gamma V power minus 1. So I'm writing in this way, okay. If the base, okay, are same, then the power adds up, okay, and dV plus V power gamma dP equals 0. So I'm writing in this way after simplification. Now we want to find the slope of adiabatic curve or adiabatic change, okay, or adiabatic process. So I'm writing in this way, okay. V power gamma dP equals minus P gamma V power gamma V power minus 1 dV. And we can see, okay, this cancels out. Now what we get after rearranging, we write in this way, okay, dP by dV, this equals minus gamma P, okay, pressure, and we have V power minus 1, so we can write in this way, okay, we can write in this way. Now this ratio, okay, on the left hand side, this gives the slope, okay, this gives the slope of adiabatic curve. So I'm writing in this way, okay. Now let us call it equation 4. So we have this. This is equation 4. Now we can write equation 4, okay, in this way. So I'm taking in this way. This is the slope of adiabatic curve, okay. So this equals gamma. So I'm putting negative sign or associating negative sign with P by V. Now we can see from equation 3, okay, minus P by V is the slope of isothermal process. So we can write dP by dV for adiabatic curve or process, okay. This equals gamma times, okay, and this ratio, okay, inside the bracket is the slope of isothermal curve. So we have this. So finally, we have shown that, okay, the slope of adiabatic curve is gamma times the slope of isothermal curve. And since gamma is greater than 1, okay, so we have this. Therefore, the slope, what we get? Slope of adiabatic curve is greater than the slope of isothermal curve. So it means that adiabatic curve is steeper than, okay, it is steeper than isothermal curve. So we need to understand this.